महोदय किं पृच्छति भवान्?
प्रायः कति जनाः भवन्ति?
100पर्यन्तम् आगमिष्यन्ति अत्र। अनन्तरं लैव् मध्ये अपि चलति किल, लैव् मध्ये अपि चलति।
ओ अस्तु।
Was there any feedback link provided yesterday, madam? I have no idea. So Dr. Ramakrishnan is asking. Actually, yesterday it was not provided, but we have spoken and today it will be provided, sir. And we will also try to make arrangements to give certificates to those who attended yesterday. Upari Pashyantu, the meeting is being live streamed.
आमामाम्। इतः परम् अग्रिमकार्यक्रमः अपि भविष्यति वा? 7:30 अन्य कार्यक्रमः अस्ति वा?
न एकमेव भवतः भाषणं तदेव कर्तुं शक्यते। प्रतिदिनम् एकमेव इदानीम्
1 घण्टात्मकं कार्यक्रमः एकमेव अस्ति प्रतिदिनम्। अस्तु
अद्य भवतः कार्यक्रमः मात्रमेव जी।
ओ अस्तु अस्तु।
तदपि उक्तं प्रतिदिनम् 1 घण्टा। अद्य भवतः
प्रतिदिनम् 1 घण्टा।
माम् इदानीं प्रारम्भं कुर्मः किम्?
करणीयं कुर्मः। अनुषा अस्ति वा योजिता अत्र? अनुषा अस्ति। आरम्भं कुर्मः।
इदानीं तु जनाः न्यूनाः एव
आगमिष्यन्ति अचिरात्।
आमां तदेव प्रतीक्षां कुर्मः वा नो चेत् आरम्भं कुर्मः वा इति पृच्छामि।
परन्तु समयः जातः किल, अधिकाः प्रवेष्टुं न शक्नुवन्ति। आरम्भे अस्माकमपि श्रमः आसीत् किल, प्रवेशे काटे श्रमः आसीत्, तत्र किञ्चित् समस्या अस्ति अत्र। तस्मात् अद्य किञ्चित् लैव् स्ट्रीम् मध्ये अपि चलति किल, अधिकाः तत्र पश्यन्ति।
भगिनी मम एतद् तद् पीपीटी शेरिङ्ग् कथं करणीयम् इति अत्र
अहम् इदानीम् अनुमतिं दास्यामि, तदानीं कर्तुं शक्नोति भवान्।
अस्तु अस्तु भवतु यदा ददाति अहं तदा वदति तदा अहं करोमि।
भवान् तत्र शेर् इति अधः अस्ति किल, तत्र कर्तुं शक्नोति वा? तदानीम्
एण्टैर् स्क्रीन् इति अस्ति। आमां सत्यं
तदेव।
अस्तु तद् गूगल् मीट् मध्ये अस्ति। आमां
साई श्रेया इर्कियम्मा मीटिंग ला?
yes ma'am इर्कियम्मा।
ओके तर्हि वयं प्रार्थनां इदानीं कुर्मः, तदनन्तरं कार्यक्रमस्य आरम्भः भवेदिति। नमः सर्वेभ्यः। I request Sai Shreya to sing a song so that we can all pray and begin this program.
गजाननयुतं गणेश्वरं गजाननयुतं गणेश्वरं गजाननयुतं गणेश्वरं भजामि सततं सुरेश्वरं श्री गजाननयुतं गणेश्वरं भजामि सततं सुरेश्वरं श्री गजाननयुतं गणेश्वरं भजामि सततं सुरेश्वरं श्री गजाननयुतं गणेश्वरम्। अजेन्द्र पूजित विघ्नेश्वरं अजेन्द्र पूजित विघ्नेश्वरं अजेन्द्र पूजित विघ्नेश्वरं गणादि सन्नुत पदपद्मकरम् अजेन्द्रपूजित विघ्नेश्वरं गणादिसन्नुत पदपद्मकरम् कुञ्जरभञ्जन चतुरतरकरं गुरुगुहाग्रजं प्रणवाकारं कुञ्जरभञ्जन चतुरतरकरं गुरुगुहाग्रजं प्रणवाकारं गजाननयुतं गणेश्वरं भजामि सततं सुरेश्वरं श्री गजाननयुतं गणेश्वरम्. Thank you, ma'am.
Thank you, Shreya. That was a wonderful rendition. Thank you.
Thank you, ma'am.
I have great pleasure in welcoming the resource person of today, Shri Venkatakrishnan ji. We are eagerly waiting to listen to your presentation, sir. My heartfelt welcome to the members of the Global Sanskrit Forum, the management and the authorities of Sita Lakshmi Ramaswamy College, Sharada College in Salem, Vivekananda College from Madurai, Guru Nanak College, and Etraj College. I welcome everybody and to witness the scholarly presentation of the day. Thank you so much. I now request 1 minute. Oh my God, what did I do? Okay. Yes, I request Dr. Sridhar to speak a few words to welcome the gathering.
श्री गुरुभ्यो नमः। या देवी स्तूयते नित्यं विबुधैर्वेदपारगैः सा मे वसतु जिह्वाग्रे ब्रह्मरूपा सरस्वती। वैश्विक संस्कृत मंचः तमिळ्नाडु प्रान्तेन सह तमिळ्नाडु प्रदेशे विद्यमान महाविद्यालयाः मिलित्वा संस्कृत सप्ताहः इति महोत्सवः ह्यः प्रभृति प्रारब्धः। अद्य तावत् द्वितीय दिवसः। अस्मिन् शुभदिने भारतीय गणितम् अथवा वेदगणितम् इति शीर्षकम् अवलम्ब्य अस्मान् उद्बोधयितुं विराजन्ते अस्माकं प्रिय गुरवः श्रीमान् वेङ्कटकृष्ण महाभागाः। तानहं सविनयं नत्वा मदीय नमोवाकं पुनः पुनः निवेद्य स्वागतीकरणे महान् मोदो मे मनसि जायते। सर्वेषां सरल अवगमनार्थम् इतः प्रभृति आङ्ग्लभाषायां जिगदिशामि। The Global Sanskrit Forum Tamilnadu Prant and several colleges across Tamil Nadu have organized a wonderful program called Sanskrit Week Celebrations, which was commenced yesterday. Today is the second day. Now, in this session, we are having Mr. Venkatakrishnan ji, who, in spite of his very busy schedule, agreed our invitation and who has come forward in this online forum to enlighten us on the vibrant and vital topic Veda Ganitam Athava Bharatiya Ganitam. I welcome you, sir, on behalf of all the institutions. I extend a warm welcome to our resourceful resource person. Next, I wholeheartedly welcome all the dignitaries, all the secretaries, all the Secretary Swamiji from the host institutions, all the Kulapati Swamijis from the host institutions, principals, vice principals, dean and controller of examinations, and IPSC coordinators, all the staff members across the country, across this country, who have gathered here to listen to the wonderful topic of this day. Last but not the least, I have great pleasure in welcoming all the participants who have gathered here to listen to this topic in this online mode and who are also witnessing this wonderful lecture via YouTube. Thanks once again. I also thank the Almighty for providing me this opportunity. Thank you. Itisha.
Thank you for those wonderful words, Dr. Sridhar. I now invite Dr. M. Uma Maheshwari to introduce the guest for the day, the guest speaker for the day. Thank you. Dr. Uma Maheshwari, you can unmute.
Namaskaraha, Namasarvebhyaha. It's an honor and privilege to introduce our young scholar R.S. Venkatakrishnan Mahodayaha, who is associated with Samskrita Bharati for more than 15 years, and now he is associated as a research uh, scholar in the project of Indian mathematics in Sanskrit Promotion Foundation, Delhi. Basically, Mohodaya is a mechanical engineer, and he was a faculty in engineering college, private Indian engineering college, and he seems to be a versatile person. He has done his post graduation in music and post graduation in Sanskrit as well. Music he did in Madras University, and MA Sanskritam he has done in Shastra University, and now he is working at KV Sharma Research Foundation as a worker of Sanskrit Promotion Foundation. It's a big team. Sanskrit Promotion Foundation किं वदामः एक संस्कृतभारतीतः उद्भूत एक आर्गनैसेशन् अस्ति, एका संस्था अस्ति. तत्र भारतीयज्ञानपरम्परा दृष्ट्या सर्वविध भारतीयवैज्ञानिक सांस्कृतिकविषयाणां विषये शोधः, पाठनं, पाठ्यपद्धति, पाठ्यपुस्तकानि, इदानीं संस्कृतमाध्यमेन सर्वे अपि यथा पठितुम् अर्हन्ति तादृश प्रथमकक्षातः द्वादशमकक्षापर्यन्तं सर्वेषु विषयेषु संस्कृतमाध्यमेन बोधनीयम् इति पाठ्यक्रमाः, पाठ्यपुस्तकानि सर्वाणि एषा संस्था एतदर्थं कार्यं करोति. तत्र एक अङ्गीभूतः अस्ति आर्.एस्. वेङ्कटकृष्णन् महोदयः. विशेषतया भारतीयगणितशास्त्रे अस्य महोदयस्य योगदानम् अधिकम् अस्ति. I have a book here. This is Bharatiya Ganita Parampara Pustakam of Samskrita Samvardhana Pratishthanam, that is Samskrita Promotion Foundation, and one more book, a primer on Indian mathematics. So all these are authored by a team of members, and the team leader is our MD Srinivasan Mahodaya. He was conferred with Padma Shri Award recently. So under his guidance, it is a privilege that R.S. Venkatkrishnan Mahodaya is working under him, and he is one of the authors here. And other authors are Rama Kalyani ma'am, M.V. Mohan Mahodaya, and Kartikeya Mahodaya. So there are 8 they are still working, and we have Aryabhatiya Ganita Pada Pustakam, where Shlokashah, Anvayah, Tatparyam, Anantaram, Tasya Padhati, solutions to the solutions for all, how to take Samskrita Vijnana Vishayaha in Sarala Samskrita. Such books are there, and they are in the team of authors. and Mohoday is one of them. And recently, they have authored a 1,000 pages book, Leelavati, which has 272 shlokas. It is an ancient Indian mathematical treatise. It's a really a great contribution. It is yet to be released. We are actually waiting for that pustakam, pustakarpanartham. Then, other than that, currently the ongoing projects which Mahodaya is also involved is Bharatiya Ganita Pravesha 2, same Bharatiya Ganita Parampara 2, and Bija Ganita. So like that, it's an unending process, and I wish he's such a young research scholar and great he's in the level of scientist, actually, we can say. So to have such a young person and who will be a real inspiring person to all our youngsters, the college students who are participating here in the Zoom meet as well as in the YouTube link, uh, definitely I'm sure that they will be getting a big inspiration and many more inputs, and they'll cheerfully think about their own contribution based upon his presentation. I deem it a privilege again to introduce our beloved R.S. Venkatakrishna Mohodaya to this honorable research scholars. Thank you. Namaskara.
Now I request Dr. Venkatakrishnan sir to please go ahead with the presentation of the day so that we can all enjoy listening to you, sir. Sir, you need to unmute, sir.
Is it okay now?
वेङ्कटकृष्ण महोदय यदि लीलावती पुस्तकं हस्तगतं स्यात् तर्हि तत् प्रदर्शयितुं शक्नोति उषामाता मूकत्वेन अस्ति इदानीं कृष्णं प्रार्थयामः मूकं करोति वाचालम् इति प्रार्थयामः
Our Leelavati book, Asmakam Leelavati Pustakam. This is our Leelavati book. This is yet to be released. This will be released soon, either in this month. So we are also expecting it. So this is our Leelavati book, as Dr. Uma Maheshwari Bhagini mentioned. It is a book of 1,000 pages. The book of 1,000 pages.
And the team has actually prepared more than 7,000 questions on this Leelavati. Saptasahasradikam prashnaha balakanam yatha samyak tatra gatihi bhavet तथा वेङ्कटकृष्णः कार्तिक महोदयः अहमपि तत्र एक भागं स्वीकृतवान् एवं संवर्धितं बहु समीचीनं दृष्ट्वा एव प्रेरणादायकम् अस्ति तद् पुस्तकम् अस्तु
Sir, Mohanji, I request you to tell this in English also, as many of the students from mathematics departments have joined.
Namaste. Bhaskaracharya has covered the arithmetic and geometry entirely, and a very small part of algebra in Leelavati, around 272 verses. This was an ancient mathematics textbook, conventional regular textbook in the ancient days. Even today it continues to be in many places. And what children learn today in NCERT book, you can find almost this algebra and geometry part entirely. You can Venkatakrishnan, in fact, was involved in mapping the NCERT syllabus along with the verses in Leelavati in the initial stages, around 2017-18, that period. There we could map every topic of NCERT syllabus, what children are learning from 6th, 7th, 8th syllabus, 9th to some extent. And 9th, several things are written by Bhaskaracharya in another work called Bijaganitam, almost equally voluminous work. It is entirely dedicated to algebra. And many anecdotes are there. We have added around 12 appendices. The very interesting aspects of Bhaskaracharya. This is one work which is unparalleled because the Bhaskaracharya uses around 25 chandas for only these 272 verses. So we have heard Narayana Bhattadri using around 25 to 30 Chandamsi, spanning 1100 and odd shlokas. But here Bhaskaracharya does so only within a short span of this one. And he uses the context and relevant chandas wherever possible. For example, in Krakacha Vyavaharaha, there is a meter called Rathodata, where it as though sawing the wood. So while calculating the surface area of the wood which is sawn, that is the chanda is very relevant. Similarly, for sum of series, where the children learn in a 9th standard 1 plus 2 plus 3 up till n is equal to n into n plus 1 by 2. So for saika pada ghana pada ardhamathai kadyanka yuti kila sankalitakya. Like that, the chandas also is very apt, as though a series, a train is moving or something like that. Our great stalwarts like Vedanta Deshika, Kalidasa, they all employed all this. Bhaskara also is a modern Ganita Kavi. So all those aspects have been brought out in the scheme of authors, where Venkatakrishna is also one amongst them. And it is a must read for everyone. Moreover, those who those who don't know Ganitam and they are interested in Sanskrit literature, around 1086 Samasta Padani, how to do Vigraha Vakyam for such words are also there. Similarly, around 980 Sandhi, this one, Chedaha also are there. All the 4000 odd words of Bhaskaracharya have been translated into simple Sanskrit as well as in English also. And those who don't know Sanskrit but have interest in mathematics, for them, without touching the Sanskrit part also, they can easily relate to all the English words as well as the explanation given also. So for it caters to both the types of people, those who are allergic to mathematics but want Sanskrit literature, those who are interested in mathematics but are not well versed in Sanskrit. And it also creates an interest to amongst the people to learn study the original. There's plenty of places. Literary beauty is also there in mathematics. That is something which is quite surprising. Literary beauty in mathematics is seldom even thought of. But here you have Bhaskaracharya showing literary beauty, alliterations, and many alankaras also. Then sense of humor. For fraction of fractions, in that he gives an example of a miser giving a donation, giving charity. So how can a miser commit himself to charity? Is a problem befitting the context of fraction of fraction of fraction of fraction of fraction of fraction. That's how he says. So wonderfully, the problems are also given. All these things you can. Rest of the details you can ask. Venkatji, Bhavana Grenade.
Namaste to all. First of all, thank you for the kind welcome and the kind introduction by Dr. Uma Maheshwari Bagini. Thank you, one and all, for coming here to patiently listen the lecture. So, let me start the lecture now. Krishnaya Vasudevaya Jnanamudraya Yogine Nathaya Rukminishaya Namo Vedanta Vedine Apadamoli Paryantam Gurunam Akritim Smaret Tena Vignaha Pranashyanti Siddhyanti Cha Manorathaha. Shri Gurubhyo Namah. Let me start the lecture. So I will just share the presentation. I have made the presentation into two. So I will just start it. Okay. So first let us see some thing about Samskrita Bhasha. So Sanskrit language itself, since I came to know that many mathematics people are also there and also Sanskrit people are also there. So let us know about the Samskrita Bhasha, some wonders of Samskrita Bhasha. I am not going to go deep into it, just something about Samskrita Bhasha and some sciences other than mathematics also. Just something we will see about it about 5 to 10 minutes, and then we'll directly go to the mathematics part. So first, when we talk about Indian knowledge systems nowadays, we speak about Indian knowledge systems or Indian sciences or whatever it may be, we should first learn about or know about the Vedas. So Vedas are the base or the embodiment of knowledge for the entire humankind, or at least for the entire Indian knowledge systems. We know that how many are the Vedas? There are 4 Vedas: Rig Veda, Yajur Veda, Sama Veda, Atharvana Veda. And also, to read the Vedas fully or to know the Vedas rightly and completely, we have 6 Vedangas like Shiksha, Vyakaranam, Jyotisha, Niruktam, etc. There are 6 like this. So these Vidyas are there, and also these Vedas are also divided into 4, internally divided into 4. The Vedas are externally divided into 4, classified into 4, but each Veda is internally divided into 4. We see it in the screen. Samhita, Brahmanam. Let me actually slide show it. Samhita, Brahmanam, Aranyakam, and Upanishad. So Samhita, Brahmanam, Aranyakam, in each Veda contains all these 4. So Samhita, Brahmanam, Aranyakam, and Upanishad. Out of this, we generally say that Upanishad are the one which discuss about the world or God or self or the soul. Upanishads discuss about these things. And Samhita, Brahmanam, and Aranyakam generally talk about the way yagas, yajnas, how to go to Swarga. Normally, this is a general classification. But when we go deep into Vedas or when we delve into Vedas, so what we come to know is that there is no classification of Paravidya or Aparavidya like this. So these things talk about these, and these things, all the things talk about all. So that is a great sukshma there. When we go deep into the Vyakyanakaras, they say that when we see the Vedas in the terms of Parabrahman, when we interpret Vedas in terms of Parabrahman or so, with the use of Brahma Sutras, they are Paravidya. But when you talk about all other things except Parabrahman or the soul or the self or the world, when we talk about the nature of the world or what are the things in the world, that naturally comes into the scientific part. So these are called Aparavidya. So Paravidya talks about the Parabrahman. Aparavidya talks about the entire world or the entire creation of that Parabrahman. So these are the classification of Vedas. So now from this we come to know that this Aparavidya is the one which is the base of all sciences, including mathematics. So we'll be seeing something here. So now let us see about the Sanskritam language. So just a glimpse of it, an assumption. What is general assumption on Sanskritam? Cannot be spoken, not scientific, not modern, redundant. So how it is scientific, we are going to see here. It's not modern. How it is modern also, we are going to see here. Because as Mohanji here, Dr. Mohan sir, he also mentioned about some beautiful verses, and the verses talking about mathematics and beautiful, all literary beauties containing it. So it is a versatile part. Only a versatile genius of both the literature and mathematics only can create such a type of work like Leelavati or Aryabhatam or so. So such people were there. They were more modern or more scientific than the people whom we talk about now. Because now if we take scientists, we cannot guarantee that they may be interested in literary things also. No, not at all. Maybe some people may be interested. It might be exception, or there may be it might be the individual choice, but that is not the case. That is not a general rule now. And when we talk about, when we take a literature person who is interested in literary activities, he will not be interested in science or mathematics and all. He will be talking about literature. He will be thinking in a literary line alone. In our ancient days, our people were such a versatile genius that they were well versed both in mathematics or any other kind of science, and also in the language and literary sciences. So that was their greatness. So now we say that Sanskrit can be spoken. It is trans-scientific, ultra-modern, relevant. This is the fact. So just we go about a few quotations. Albert Einstein, the great physicist or the great scientist whom we admire, he talks these lines. I have made the Gita and the Sanskrit literature the main source of inspiration and guidance for the purpose of scientific investigation and formation of my theories. So this breaks the entire myth that the Gita, or this breaks the entire myth that Rama and Mahabharata are mythologies. These are not the mythologies where we say about them as mythologies. That is the greatest myth. When we say the Ramayana and Mahabharata is a mythology, That is the greatest myth in the world. So it has been confirmed by Albert Einstein. So the Swami Vivekananda says the very sound of Sanskrit words gives a prestige and power and a strength to the race. When we talk in Sanskrit or when we do ucharanas of some Sanskrit shlokas, either from Ramayana, Mahabharata or Vishnu Sahasranama or anything, or about some these things, some scientific things in mathematics or any other science and astronomy or physics or chemistry, that itself gives the very sound, the very ucharana, the very pronunciation gives, and the very listening gives the prestige and power and strength to the race. This is also one of the reasons. This is perhaps the main reason, as pointed out by Swami Vivekananda, why all our entire science and scientific literature were also created in Sanskrit language. Mahatma Gandhi says, without the study of Sanskrit, one cannot become a true Indian and a true learned man. So this is a fact indeed. Why study Sanskritam? So Sanskrit is an old language, we know. So why study that old language? Because language is the distillation of thousands of years of collective experience. So what is a language? Actually, what does a language mean? It is a distillation of thousands of years of collective experience. When a language is, now we say it as dead language, but it is not a dead language even now. It is a endangered language, that's all. But still, this language was spoken thousands and thousands of years ago, about for a millennia, in India, throughout India, in all parts of India. When such huge amount of people have spoken this language, what do we gain from them actually? It is a distillation of thousands of years of collective experience. Whatever is written in Sanskrit now, it is a distillation of all their experiences. Whether it may be spiritual, whether it is material experimentation, whether it may be spiritual experience or it may be based on material experimentation, it is a distillation of thousands of years of collective experience. So when the language disappears, we are really throwing away that whole library of language knowledge. So even mathematicians or other people who are maybe whatever maybe their field, they should also try to learn this language. So who are the scientists of ancient India? Some of the scientists of ancient India: Aryabhatta. Aryabhatta was a person who lived in the 5th century CE, Common Era, and he was very well versed in mathematics and astronomy. Varaha Mihira was a person who lived in 7th century CE. He was also well versed in astronomy as well as astrology, and he was a mastermind person. He was a jack of all trades, not a jack, king of all trades. So he was a very versatile person. He was a wizard indeed. He has written one text called Brihat Samhita, which talks about entire, it's like an encyclopedia. There is nothing which is not inside Brihat Samhita. So that is his work. Dhanvantri, we regard him as God. We see his murti in temples also, and he was a doctor, and he is the father of Ayurveda. Vishwakarma, we know about him also. We have heard his name. We learn about him in our scriptures. He is a great founder of architectural science. Shushruta, he was a master in surgery, and Charaka was a great Vaidya, and Nagarjuna, he was a great man in philosophy, Ayurveda, chemistry, and many others. Many people were actually indeed experts, and not an expert in one. They were actually wizards. Wizards means experts in many fields, not one. So let's go. So let's know about something about physics also. When I talk about mathematics, we should not think that we know about Indians knew only mathematics and nothing about other subjects. So just I am giving a glimpse of it. So physics. Nowadays we talk about machine in physics, in science, and in engineering also we talk about machine. What is the definition of a machine given by them? It is taken from a text called Yantraranavam, which specifically talks about the yantras. Yantras means machine, that which is made to work by some power. So that those are called yantras. So this text belongs to 14th century CE. Dandaischakrais dantaischa sarani brahmanadibihi shakter utpadanam kimva charanam yantram uchyate. The system for generation of energy through motion or continuous rotation of shafts, wheels, or wedges is called a machine. How they define a machine very aptly in the Sanskrit verse form, and also they bring out the entire definition also for a simple machine or a machine. So it's very great. So speed of light were also known by our ancient people. Sayanacharya's Bhashyam and Rik Mantra says this verse is taken from Sayanacharya's Bhashyam, Sayanacharya was a great acharya who wrote commentaries on entire Vedas. So that was his greatness. So we get a 185,016.169 miles per second, but this can be more or less this value is more or less equivalent to our present value 3 into 10 power 8 meter per second. So lens. So what is a lens? So we nowadays we talk about lens in eye when we talk about some eye treatment or eye surgery, or when we talk about the ophthalmology, we talk more about lens. There are different types of concave lens, convex lens. We deal about more kinds of lens in our present scientific era. So this concept of lens was known to Indians very earlier, as early as 800 BC, in a text called Nyaya Darshanam. Actually, this text is not at all relevant to our physics or chemistry, but still these Nyaya and Vaisheshika people deal about some aspects of physics and science in their texts. So this is taken from it. Aprapya grahanam kachabhra pataspatikantari lotopalabdehe. That which cannot be perceived with naked eye can be perceived with the help of instruments with lenses made of kacha glass, abhrapatala mica, and spatika crystal. So these were also the basic concept of lens were also known to Indians. So something from astronomy. We know about the Surya Grahana and Chandragrahana, solar and lunar eclipse. The cause of eclipse, Aryabhatiam of Aryabhata talks about this. The Chadayeti Shashi Suryam Shashinam Mahati Cha Bhutchaya. Here, in a small part of verse, he gives both the solar and lunar eclipse. The moon covers the sun. During a solar eclipse, the moon covers the sun. And during the lunar eclipse, the great shadow of the earth covers the moon. So this is the concept of both the solar and lunar eclipse given in such a short form in a part of the verse or half of the verse. This is given. So what is sunrise and sunset? Actually, we say that during sunrise and sunset actually doesn't happen. It is due to the rotation of the earth. This seems to happen. But this concept was known as early as Vishnu Puranam. Actually, we Indians believe that all such kinds of Puranas were written before 5,000 years. But some Westerners say that these things were written only at 3,000 or 4,000 years back, 3,000 years back. But we Indians believe that these were written in the period of Veda Vyasa, who lived before 5,000 years. So Naivasta Anamarkasya Nodayas Sarvadas Smritaha Udayasta Manakhyam Hi Darshanat Adarshanam Ravehe. What is that? There is in truth neither rising nor setting of the sun, for it is always there, and these terms of rising and setting merely imply its presence and disappearance. So this is not there, but just appearance and disappearance only show its rising and setting. Sun doesn't actually rise or set. This was the concept known earlier. So orbiting planets. Actually, this is a great myth breaker. This verse is a great myth breaker, I will say. So because Siddhanta Shiromani was a text written by Bhaskaracharya, second Bhaskaracharya. This we call him as Bhaskaracharya II. It is a great entire text, astronomical text, containing dealing many concepts of astronomy. It was written as early as 12th century CE. Let's note this point. Here in this verse from the Siddhanta Shiromani Bhuvana Kosha, chapter 6, he says, actually it is not 528 CE, it is 1128 CE. Actually it is typed wrong. Sorry for it. Akrishti Shaktischa Mahi Taya Kastam Guru Swavimukham Swashaktya Akrishyate Tat Patativa Bhati Same Samantatva Patatvyam Khe. Massive celestial bodies are attracted powerfully towards the earth by her own gravitational force. This gravitational force, gravity, grahanam. The grahanam we say in Sanskrit as grahanam. Grahanam means catching or getting. So gravitational force, this word is more or less it seems similar to the word grahanam. But Bhaskaracharya takes the word for gravity as Akrishti Shakti. That the Bhumi, the Earth's Akrishti Shakti is only the gravitational power. He says that massive celestial bodies are attracted powerfully towards the Earth by her own gravitational force, and they appear to fall as a result of such attraction. But when equal forces act on a body in space from all sides, how can it fall? He says. So the concept we have to know. We say that Isaac Newton only founded this concept of gravity in the 15th century. But since alas, since we did not know our ancient text, Bhaskaracharya very clearly in a verse gives this. If we'd have known some Sanskrit, or since for the past 1,000 years we were in the period of slavery, one by one, one by one, one by one, we were not able to access our text. Our texts were lost. People, in saving their own kith and kin, in saving their own women folk, they lost all these things. They lost interest. They were not able to study. Slowly the parampara got cut down. So the great entire the learning parampara, the entire jnana parampara of the glorious Bharat cut down because of the slavery. This is the main point we should understand, that due to slavery only all our jnana parampara got cut off. Otherwise, we would have been a very glorious jnana. If the jnana parampara would have continued, we would have been a glorious jnana parampara, and we would have. Now also we are doing it. We are trying to doing it. We are also doing in many fields. We would have guided the entire world based on our knowledge if the our jnana parampara itself would have continued still. So we got all the jnana parampara cut down. We are not now knowing why this verse was said. All these things. If our great Guru parampara would have continued, in this tradition, all this knowledge would have been passed to us. So we would have a great rich treasure of knowledge. Just like we lost great amount of money, and India became very poor for the past from the 17th century BCE. Likewise, like that, we also lost our great knowledge source also. So that's the thing. Now we will go to the mathematics. Now let me go to the next PPT. So now we come to the great mathematics in ancient India. So now let me highlight some Indian contributions of our Indian contributions. Actually, we should remember that whatever contribution for the next 3 or 4 slides, I will be reading some contributions which you might be seeing in the screen also. These contributions are not without any references. The sources, the contributions which are with references only, we have highlighted here, and that too only very few have been highlighted here. There are many more. So right angle triangle theorem was first discovered by Baudhayana, which we call it as Pythagoras theorem now, Pythagoras theorem. It was rediscovered or repeated by Pythagoras. It should be renamed from Pythagorean theorem to Baudhayana theorem. So Baudhayana, he was a great rishi who wrote Shulba Sutras on the, I was talking about the Vedanga, Kalpam, and a branch of Kalpam contains Shulba Sutras to highlight the shapes, to give the shapes of Yaga Kundas. The Yaga Kundas were not only in square or rectangular shape, they were many shaped actually. Whatever geometrical figure we see now, or the figure we study in geometry nowadays, all these figures were used by our ancestors to design Yaga Kunda. So for Yaga Kunda, they needed accurate measurement for it. For when they were using some calculations, out of those calculations, we found out this theorem. That is, the entire Indians found out this theorem. So we had such an accurate calculation of Pythagoras theorem as early as 2000 BCE. So, but actually Pythagoras found out this theorem in 540 BCE. We have to see the lines, not from Shulba Sutra, and the next Aryabhatta Leelavati gives the verses for pi and Pythagoras theorem. Let us see it. Calculus was first discovered by Bhaskara in 1014 CE. It was rediscovered by Michael Rolle. So logarithms was first discovered by Jain mathematicians, and Veerasena, he was also a Jain mathematician. It was rediscovered by John Napier. See the years, 300, that was 300 BC. This is 1550 CE. Trigonometry was first discovered by author of Surya Siddhanta as early as 300 BCE. It was rediscovered or used by Hipparchus in 150 CE. So the father of trigonometry is the author of Surya Siddhanta's author is unknown, but still the father of trigonometry is only him. The infinite series for sine, cosine, tangent functions, which we study now, an inverse tangent function was discovered by Madhava of Kerala. He was a great Kerala mathematician. He founded the Kerala Ganita Parampara. Entire bright tradition continued after him. learning about his teachings on mathematics and astronomy. So it continued from Madhava. It started from Madhava. So he was the founder of infinite series, but they were respectively rediscovered by Taylor, Newton, Gregory of 17th century CE. We don't say that they actually took it from. They had also these three concepts. All these concepts were rediscovered in Europe in some other time.
May I request everybody to please mute so that we can hear the speaker for the day? May I request everybody to mute?
The solution for complete quadratic equation is found in the Shulba Sutras, but it was discovered by Heron in 70 CE. It should be renamed as Heron's formula to Shulba Sutra theorem. These are the things we just proposed, but this is not the case, but we are highlighting what was there in ancient India. The formula for permutation combination was discovered by Mahavira in 814 CE. It was rediscovered by Harigon in 1634 CE. So this is the day. So let us see some mathematical terms. So for people, now we know that without any mathematical terminologies or anything, we cannot write or we cannot convey any mathematical concepts. Either it may be through verses or whatever may be the language. We need the mathematical terms. Then only we can. We need the scientific terms or the mathematical terms, whatever it may be, in that own language, so that they will be able to convey the this one. So yogaha, kshepaha. What is mathematical terms? For addition, yogaha or kshepaha. There are many more. Just I have taken two. Yogaha or kshepaha. Yogaha means yoga. What is yoga? We talk about yoga and all. What is actually yoga? So the unison of body, mind, and soul is called yoga, we can say, or the unity of Atman with Parabrahman is called yoga. That is the concept of yoga and yoga shastra. But when we use the word in mathematics, we just use it in the term of addition. So in whatever may be the term we hear, the concept may be the yujir yojane, maybe the dhatu. The dhatu, from dhatu we take the term. So the Sanskrit is a language which is very beautifully designed. We call it a Samyak Kritam Samskritam. So Samyak Kritam Samskritam, there are many, actually it is a very structured language. We cannot directly derail its structure, or if you want to use the word in some other form, we cannot derail its structure directly. It cannot be done so. So when a single word is used in many subjects or many shastras, each subject, each meaning of the word will go back to its own root or dhatu, and it will be very relevant according to it. We cannot use any word in terms of any other meaning without such kind of relevancy. So that is the beauty and structured way in which the Sanskrit is designed. Our great Rishi Parampara. So zero means kam, shunya. Kam means, it means akasha also. We mean it as zero. Kaharaha, infinity. Gunanam, multiplication. Gunanam means multiplication. Haranam means division. Bhuja means a side or a base of a triangle. Koti means altitude of a triangle. Karnaha means actually it is the Karnaha term actually means it is a ear. We talk about our body part, no, ear, which through which we hear. It is called ear. So Karnaha, Shramanaha, all these are called all these are terms for ear. Why this in a right angle triangle, if we see, or if we imagine some bow and arrow structure, when we imagine the thread of the bow, so when the thread of the bow, when we are going to grab it, or when we are going to drag the thread of the bow, it will assume the form of a ear. So the right angle triangle more or less appears to be a bow and arrow structure, bow structure, in which the entire thing will be there and the arrow will be clinging to it. It will be, when we tighten the arrow or drag the thread, we will see that it resembles the karna. And also one more thing. Okay, vargaha. Vargaha means square and squaring. Both the squaring and also the square. When we want to take 5 square, we say panchavargaha. If you want to use the same thing in the term of operation also, operation of squaring also, the same varga is used. Vargaha. Varga moolam means square root. Ganaha means cube, cubing and volume. Ghana moolam means cube root. Antaram means Shrayaha, Antaram, Viyogaha. There are many words, subtraction. So next one. Rashihi, quantity. So quantity means Rashihi. Gatihi means speed, movement. Akrishtihi means gravity. Samalamba Chaturbujaha means trapezium. Prishtiya Kshetrapalam means surface area. There are many terms. In our Ganita Parampara book, which our Dr. Uma Maheshwari Bhagini showed to us all, we have taken more than 300 to 500 terms we have given. In Leelavati book also, we have given such kind of this for more than 250 terms we have given. For more than 250 to 300 terms, we have given the English meaning along with the Sanskrit term. So many terms are available throughout the Indian mathematical text. So I am just to give a tip of the iceberg or a taste of a bit of honey. I just thought I can give this. So now we come to mathematics. We say that why is this mathematics needed? Because we cannot even move without mathematics. That's what Ganita Sara Sangraha, a mathematical text written by Mahaviracharya, says that whatever may be the subject you take, it may be a Vedic subject or a worldly subject, or it may be spirituality, it may be materialism. Whatever you take without mathematics, you cannot move an inch. So now when I talk about it, I say you cannot move an inch. That is also mathematics. So the verse goes like this. He has written 3 to 4 verses. He has given that Laukike, Vaidike, Vapi, Tata, Samajike, whether it may be worldly or in society, Vyaparastatra, business, Sarvatra, Sankyanam, Upayujyate. We use mathematics everywhere. Kamatantre, Arthashastre, we say Dharma, Astra, Artha, Kama, Moksha. In all the Purusharthas also, we need mathematics. Gandharve in music, in Natake, in drama, Supashastre in our cooking, tata vaidye in medicine or medical science, vastu vidya divastushu, vastu in the great things of architecture, or we say vastu vidya in ancient things. No, this should be there, that should be there. That also need calculations. Chandas, we know that prasodi. Alankara kavyeshu, Alankara shastra, kavya shastra. Kavya means we know that poetry. Tarka vyakaranadishu, Tarka shastra and grammar. Kala guneshu, in all the kalas, in all the art forms, sarveshu prastutam ganitam param. Everywhere we need only one thing. We cannot miss this one thing. This is called ganitam. Surya adi grahachareshu, in all the astronomical calculations, grahane garha sanyutau, and all the this one eclipses, trigashre chandravrittau cha sarvatra angikritam hitat. Everywhere in astronomy it has been bahuvir vipralapaihi kim. What to talk of many things? Why to talk of many things? Trilokya Sarachare. In the entire Sarachara, entire universe, in the all the 3 worlds, Yatkinchit Vastu Tatsarum Ganitena Vina Nahi. Whatever may be the thing, without knowing Ganitam, you cannot know about that thing. This is the Mahatmyam of mathematics or Mahatmyam of Ganitam. We all know it. This is not a new thing. But still, how beautifully they have brought out this thing in Ganita Sara Sangraha, in mathematics, written by Mahaviracharya as early as 9th century. So this is the meaning given. So concept of zero. So now let us see some core concepts. Some of the core concepts I may not have time to fully go through this, but some core concepts we will see. How to do addition with zero. We know that a simple fundamental thing when we go to our kindergarten or when we come to the primary school, we learn about the calculation of zero. When we add anything with zero, the number remains the same. Subtraction with zero, the number remains the same. Multiplication zero, the number becomes zero. Division, the number becomes infinity, or we say it is indeterminate. So they say yoge kam shepa samam. Yoge, when yoga means addition, as we already saw, kam means zero, kshepa samam. Kshepa means the number or the additive. The number with which we add the zero, the number becomes same. Yoge kam kshepa samam. Varga adau, in varga, in squaring, in square root, varga moolam. Varga adau means etc. Cubing and cube root. In all these 4 operations, the number varga adau kam, the number becomes the zero. When we square with something or this something, when the square of 0 is 0, square root of 0 is 0, cube and cube root of 0 is 0. Kabajitau rashihi. Kabajitaha rashihi kaharaha. So the Bhaskaracharya's time says that when zero is, when number is divided by zero, it becomes infinity. Ka haraha. Ka haraha. The number becomes now ka haraha is a beautiful term in Sanskrit which says ka haraha yasya saha ka haraha, which means ka kam haraha hare yasya saha. The number zero, which is haraha, is denominator. When the number zero is present in denominator, it's called ka haraha. Which says that it is previously it was taught as infinity. Now people say it as indeterminate. Here they say it as kaharaha. The number is a kahara. What is 5 by 0? It is a term called 5 by 0. So syat kha gunaha come. When something is multiplied by 0, it becomes 0. Ka gunastinyascha shesha vidau. So in another terms also it seems like this. शून्ये गुणके जाते खम हारश्चेत् पुनस्तदा राशिः अविकृतः एव ज्ञेयस् तथैव केनोनितश्च. So if 0 is added to a number, it is the same number. The square of 0 is 0. Any non-zero number divided by 0 is kahara, infinite or indeterminate. The product of a number and 0 is 0. So this is the thing. Next one, if in some mathematical calculations, multiplication division by 0 are likely to occur frequently, then though a number multiplied by 0 is 0, should maintain the form of multiplicand. Though a number multiplied by 0, it should be taken as 1, because should maintain the form of multiplicand and multiplier 0 in rest of the operations until the final operation is reached. This is because if a number is multiplied by 0 and divided by 0, it becomes, the result is the number itself. So we cancel both the zeros and take number itself. So when some complex mathematical operations are there, we should not first take it multiply by 0 and make it as 0. So we should see the entire mathematical calculation and then we have to come to a conclusion. That's what the verse says. So concept of infinity is beautifully termed by Bhaskaracharya in a term called Bijaganitam, book called Bijaganitam. Bijaganitam actually means the concept of algebra. Now we say algebra. Actually, the terms are actually coined from Bijaganitam. So Bijaganitam is the term used in Sanskrit for algebra. So what does this term say? Asmin vikaraha kahare na rashavapi pravisteshvapi nisriteshu bahushvapi syal laya srishtikale anante achyute bhuta ganeshu yadvat. Let's see the meaning. So there is no change in infinity, kahara figure, if something is added or subtracted from the same. So asmin vikaraha kahare, in this kahara infinite quantity, na rashavapi pravisteshupi nisriteshu. So when some quantity is added or subtracted with infinity, it remains the same. Because it is already infinity, if you know something, it's going to become infinity. Any quantity is already present like this, or can we give an example for this infinite quantity? Because concept of infinite is difficult to ascertain or understand. Can we give any example for this infinite quantity? So he says, he takes the example of God Narayana. He says, Bahushvapi syal laya srishti kale anante achyute bhuta ganeshu yadvat. So in laya, in pralaya kala as well as srishti kala, in pralaya kala what happens? All the jiva ganas go and stay in the stomach of Narayana. We say Bala Gopala, we say all the Alilai, we say that Krishna is going to take a boy form and is going to lap in the he's going to take some nap, like a sleep, a short duration of sleep in a leaf. So what does it say? When in the Pralaya Kala time, when all the jivas enter the womb of God Narayana, does Narayana get any change? Or his stomach is going to get big, or if he's going to feel any uneasiness, or if he's going to get any special strengths? Nothing. He is nirvikara. He is as such. Before the jivas came also, he was the same. After the entry of jivas also, he is the same. And when Srishti Kala comes, when the entire jivas go outside for their respective Srishtis, do Narayana feel any lack of strength or feel any weakness? Nothing. He remains nirvikara. In the same way, he says, Lord Narayana, we say the Achyuta, Ananta, Govinda, there is a term for Lord Narayana. He beautifully brings out it. Laya Srishti Kale Anante Achyute. Lord Achyuta is Ananta. Achyuta means na Chutaha Yasyasaha, na Chutihi Yasyasaha, which means he does not feel any change. So in the same way, infinity also doesn't change when we add or subtract a quantity from it or to it. So this is how beautifully our ancestors have brought a mathematical concept linking in this spirituality or religion in it, and we have they have explained both the dharma, the spirituality, and mathematics to the student in a very, very nice manner. So now let us see the Pythagoras theorem. Pythagoras theorem from Aryabhatiya Ganita Pada. How beautifully we know that what is Pythagoras theorem? Base square plus altitude square equal to hypotenuse square. So how beautifully brings out in a part of the verse, Yaschaiva bhuja vargaha koti vargaha karna vargaha saha. Bhuja vargaha means base. It may be taken as a side. Here it will be taken as a base. Vargaha means square. As I already told you, the square of the base. Koti vargaha. Koti may be taken as the side perpendicular to the base or altitude. Here, koti vargaha, the side of the square of the altitude. Yaschaiva bhuja vargaha koti vargaha, the square of the altitude and the square of the base. Karna vargaha saha. It is equal to the karna vargaha saha. Yaha bhuja vargaha koti vargaha saha karna vargaha, which means the sum of the bhuja varga, which means the base square of the base and the square of the altitude is equal to the square of the hypotenuse. How beautifully in a simple verse, even in very, very shortest way, Aryabhatta the genius has brought out the entire Pythagoras theorem as early as 5th century BCE CE. That is 1500 years from now. So bhuja means base, koti means altitude, varga means square. The thing is explained here. So now let us go to the place value system. Place value system. Ekam dasham shatam cha sahasram ayuta niyute tatha prayutam kotyarbudam vrindam cha sthanat sthanam dashagunam syat. Now we talk about the place value system. From the entire kindergarten or the entire in our early school days, we are primary standards. We are learning about this place value system. What is the actually place value system? This is beautifully told in a part of the verse, in a quarter of the verse. Sthanat sthanam dashagunam syat. So when you write 25, 5 takes the ones place and 2 takes the tenth place. So what has happened now? From right to left, each digit has been increased by 10. That's what the quarter of the verse says. Sthanat sthanam, from place to place, dashagunam syat, increase it by 10. So it beautifully goes by 10. This is the entire basis of the mathematical system. This is the entire base of mathematics. This was known to us as early in the days of Vishnu Purana. Even Vishnu Purana quotes a verse for this and names the digits. And what we do, Aryabhatta has named the digits till 10 power 9, but Vishnu Purana names till 10 power 18. Ramayana, our Valmiki Ramayana, names it till 10 power 62. So this is the place value system. So 10 power 9, what is Eka, units place, Dasha, tens place, Shata, hundreds place, Sahasra, thousands place, Ayuta, 10,000 place, Niyuta, 100,000 place, Prayuta means millions place, Koti means 10 millions, that is Koti, we say now also it's in prevalence. Arbuda means 100 millions place, Vrinda means 1,000 millions place, or respectively place to place. Now we will have a question. What is there naming some big numbers or naming the place values? What is there? Because now here we should understand no country other than India as early as in these times knew more than 1000. 10 that is 10 power 3. They did not name the numbers, they did not have any numbers. That just maximum, if they knew, means they knew only 10 power 3. In later days, only before 200 300 years, something when they had a need to do it, they started. But in India, we had a need from the early days, from Vishnu Purana days and Ramayana days. We had a need. So Ramayana names about the places of numbers till 10 power 62. In Ramayana days, in Ramayana, Valmiki Ramayana actually gives these verses. So without this place value system, the entire mathematics will be a standstill. Because imagine here, without this 25 or 35, now we write in digits. No, imagine just write these digits and in a Roman value. So 56, write a 56 digit in Roman value and 65 digit in Roman value, and try to add this. because the Roman value digit what we write now, this Roman system of numeration does not follow this place value system. So without this place value system, you cannot do a simple addition also. Without simple addition, mathematics will not go forward. But for the place value system, the entire mathematics is zero. This place value system was given to the world by India as early as the Vedic days, or as early as the Vishnu Purana days. That is around 4,000 or 5,000 years. So Indian mathematics is the base for the entire world mathematics, or the entire scientific discoveries what we see now. Without this, nothing would have been possible, literally nothing. So huge numbers. I was telling you the Ramayana verses Sugrivo Balinam Hatva. The Ramayana context is an interesting concept. This goes so Shuka and Charana were the two Rama Ravana Yuddham had begun. Shuka and Charana were the two people who came to see about know the whereabouts of Rama's army, and then they were informers actually, informers of Ravana, but actually they were caught by Vibhishana. Vibhishana catches them red-handed, and he brings them to Rama. Rama actually says that let them see whatever they want and then go and inform Ravana. I am least bothered about it. I am only concerned about my strength. My strength cannot be weakened by such kinds of acts. So Vibhishana leaves them. Rama leaves them. Rama pardons them and leaves them. They return to Lanka. They go back to Lanka, and they inform Ravana about Rama's army. When they open their mouth about Rama's army, they start to list out about these numbers till 10 power 62, because they wanted to say that so much amount of men were present in Rama's army. That is till 10 power 62. So that was the need we had, because we had that much population those days itself. We had a need for counting them during some such kind of yuddham days and all, war days, days of warfare. So we had to do such things. We had a need to do so. We had entire huge numbers. This is this Valmiki. These verses are from Valmiki Ramayana, Yuddha Kanda, Sarga 28, verse 33 to 42. You can take any Valmiki Ramayana book, go to this reference and check these verses there. They are still present. These talk entirely about mathematics. They talk about the value till 10 power 62 and nothing else. So now in Bijaganitam, I will just take just 7 more minutes. I will finish it by 7:45. Addition and subtraction of integers. Bijaganitam, yoge yutihi syat. So we addition integers. How we add or subtract integers? So it talks. These verses talk about this. This is a verse taken from Bijaganitam, which is an entire book dedicated to the algebra, written by Bhaskaracharya too, in 12th century. Yoge yutihi syat kshayoho svayoho va dhanarnayor antarameva yogaha samshodhyamanam swam ridatvam eti swatvam kshayaha tadyutihi uktavaccha. So what happens? The preliminary addition and subtraction what we study now in mathematics, these were known known to India as early as 12th century. While adding two positive or negative numbers, result is the sum of the amplitudes, and it will be positive or negative according to the nature of the factors. So we when we add or subtract a positive and negative number, we know that the sign becomes that of the greater number and all. The same concept is the sum of a positive and negative number will be equal to difference of their amplitudes, and it will bear the sign of the larger of the two factors. Whatever we see now, this is a basic concept for algebra. This was known to our people as early as 12th century. So why we know about this? Now we will have a question that whatever may be the thing, the same concept we are studying. No, that's not the case, because when we know about such contributions, we are motivated to do further contributions in India, so that we take India to new heights. Why many people in India are not motivated towards science or mathematics? Because we actually do not know the contribution of mathematics or science of our own Indians. What we know now is all the entire mathematics and science, or whatever may be the subject, is were entirely discovered by the Westerners or other foreigners only. We Indians do not know anything. We knew nothing. We had nothing. That was the thing which were taught to us. But that is not so. Only if we know that all the basic concepts were present as early as 12th century, before people started thinking about it, then only we'll be able to appreciate our India, and we'll be motivated to do more such kinds of discoveries in the future. So the process of subtraction is equal to addition with the sign of the subtractant change. The same thing. So now let us come to the concept of pi. So Aryabhatta, as early as 5th century CE, talks about pi. What is pi actually? The C by D, the ratio of circumference by diameter. Actually, it is not a definite number. It is irrational number. It goes on and goes on and goes on. That concept is also written by the Bhashyakara Bhaskara one for this very verse in Aryabhatta. He writes that he discusses about irrationality of the pi number. Now it does not stop, it always moves on. It's not a rational number. He talks about it actually as early as 7th century CE. The Bhaskaracharya one talks about the irrationality of pi while commenting about this verse in his Bhaskaracharya commentary, Bhaskara Bhashyam. So Chaturadikam Shatamashta Dvashashti Tata Sahasranam Ayutadvayam Vishkambasya Asanno Vritta Parinaha. Asanna. So they say that this is the pi value is not this one. They taught in this sloka he gives 3.1416, but he says that this is not the right value or exact value. This is asanna means nearby, nearer value. That is an approximate value. They also know that concept of pi cannot be exact. So what is the C by D as given by Aryabhatta in this verse? 62,832 for the circumference. He gives this value. D for diameter, he gives 20,000. He says that 3.1416 is the value as discovered by Aryabhatta. Now, the same pi is discussed in Leelavati by Bhaskaracharya 2 in 12th century. He says that the verse is like this. Leelavati 199th verse. This one says that Bhaskaracharya starts the concept of circle by giving Parithivyasa Sambandha. So he says that we can get different values to get the value closer and closer, but we cannot always reach the exact value. So when the diameter is multiplied by 3927 and divided by 1250, then a closer approximation, that is value of circumference is obtained. Or when diameter is multiplied by 22 and divided by 7, the circumference is obtained. Is gross and easier for practical calculation. That is the very value now which we use now. 22 by 7 was known to Bhaskaracharya as early as 12th century CE. So the square and squaring. So this is also a beautiful verse by Aryabhatta in Aryabhattiyam. Vargaha Samachaturashraha Sadrishatvayasya Samvargaha. So what is the Vargaha means square, the geometrical figure square. He says Samachaturashraha, that figure which contains the sides equal sides, that is called Vargaha. And also what is meant by Vargaha? Squaring. Sadrishatvayasya Samvarga. Samvarga means product. So Sadrishatvayasya Samvarga. Sadrishatvaya means what? The similar quantity. Similar quantity means when we take 5, the other quantity is also 5. So 5 square is 25. That is the concept of Varga or squaring. So now in English we use the same word square and squaring, square for the operation and the figure, geometrical figure. In the same way, in Sanskrit also they were using the term Varga. So how beautifully in a half of the verse he brings the concept of square also and also the squaring, and for both he uses the same term. So how genius were our ancestors, we should appreciate it. So if for square root he gives a big algorithm. Bhagam Hareda Vargan Nityam Dvigunena Vargamulena Vargat Varge Shuddhe Labdam Sthanantare Moolam. So he gives the square root, and also for cube and cubing also. For cubing also he gives the same thing. Sadrisha Trayasya Samvargaha Ghanaha. So what is meant by cubing? It is a multiplication of the similar quantities 3 times. Sadrisha Trayasya Samvarga. Three similar quantities. Multiplication of 3 similar quantities or same quantities. Samvargaha Ghanaha Tada Dvadashashrihi Syat. That is, it contains 12 sides. So having 12 equal edges is called a cube. The volume of the cube is the continued product of. So one more thing is also added here. Since this is cube, volume is also called ghanaha or ghanapalam, they say. So it is also, what is volume of a cube? So volume of a cube is the multiplication of its sides, the cube of its sides, no, a cube or s cube we say. So that is also given here. So this is what. Then cube root algorithms are also there. Then it goes actually as it is. So many, some more concepts are also there. So but I stop the lecture here. So I have tried to give a glimpse of the Indian mathematics, and also talk about some granthas with this exact reference. Normally we have a small drawback. So we talk about many contributions of Indians, but we do not talk about their exact references, their verses or anything. So my aim, or our team's aim, is to bring such books which contain the exact reference, the exact verse with its English meaning, with its Anvaya in Sanskrit. The Sanskrit part should also be taken care of, and also English meaning should also be explained in meaning, and also some mathematical part should also be taken care of. So that is the thing in which mathematical verses can be dealt with. So that's what we are doing in this small lecture. I have tried to give a short glimpse of the Indian mathematics. There are many things to learn. If you want to learn more, I would suggest you, or I would request you, to buy the Bharatiya Ganita Pravesha, a primer to Indian mathematics, which our Dr. Uma Maheshwari Bhagini showed in the beginning of our lecture. Please buy that book. This book can be brought from the internet itself. You can order the book online. It will reach your house. That is Sanskrit Promotion Foundation is our company's name, or our samstha, or our foundation's name. So you type Sanskrit Promotion Foundation bookstore in the online in Google itself. You will the bookstore page will be opened. You go to that book, Bharatiya Ganita Pravesha. It is an English book. Entirely, it's an English book. It talks about Sanskrit verses. It contains Anvaya. It explains the meaning in English. Those who are really interested in Bharatiya Ganita Pravesha or Bharatiya Ganita, you should start with that book. Anybody can learn that book. It has been designed in a very easy manner. Please go to that online bookstore. Please go to the online bookstore and purchase that book. It will reach you within a short span of time. You can learn more about Indian mathematics in that book. And we are in the process of bringing the Bharatiya Ganita Pravesha second part also as a continuation of that series. So that process also going on. We hope that it will also be brought earlier, as early as possible. So please try to get that book and learn it. And also when we go to the second book, you can also take the second book when it is getting released. So that's what I have to say. Thank you, one and all. Thank you for all for your pleasant and patient listening. Thank you, one and all.
Ganesh ji has put in a slide asking for the previous slide once, please. Ganesh ji, you please unmute. कृपया भवान् आगत्य वदन्तु किं द्रष्टुमिच्छति इति सः प्रदर्शयिष्यति महोदयः. गणेश जी, तत्र chat कृपया वदन्तु.
मैम जो रामायण का जो संदर्भ दिया था उन्होंने, सर जी मैं वही संदर्भ देखना चाहता हूँ.
Oh, okay. I will show you.
जी सर.
I will show you. So these are the shlokas from Ramayana. Since due to the want of time, I did not read the shlokas. This is the reference.
Yuddha
Kanda, Sarga 28, 33 to 42 verses. Actually, around 10 verses.
Thank you, sir. That was a torrential rain of significant points from mathematics and connecting it to the ancient knowledge of our Sanskrit texts, which made all our hearts swell with pride, recollecting the ancient tradition and the heritage in the rich language of Sanskrit. I now request Ramesh sir from Guru Nanak College to propose the vote of thanks for the day.
Before
सर्वेभ्यः
that,
नमस्कारः।
before that, if anybody having any doubts, you can clarify.
Yes, somebody wants to give a feedback on today's presentation, or even you want to share something, you may please do so, after which Ramesh sir will propose the vote of thanks.
Sir,
Yes, sir.
sir, I am having a doubt, sir.
Ah.
Sir, you told that bhuja means that base of triangle, right?
Yes.
Sir, I am having a little bit confusion between that bhuja and this base of triangle bhuja.
Okay.
Sir, actually, can you stop sharing the screen, sir? Because we are
Yes.
able to see multiple screens on the. Yes, thank you, sir.
Actually, this as I was telling you, sir, this bhuja, though it doesn't literally mean the bhuja, it is used. It is a side actually. It's a side of a triangle, or side of a rectangle, or a side of a figure. Whatever may be the thing, you can take it as a side. That's all. Here in this triangle, we take it as bhuja, koti as base, and the even you can take bhuja for the perpendicular and the koti for the base. Nothing. It is not that much wrong. But still, as a colloquial this thing, we use just bhuja for the base and this one. That's all, sir. There is nothing more. In this here.
Sir, you have explained very well, sir.
Thank you. Thank you so much, sir.
Anything else from the participant side? यः कोऽपि वा या कापि वा यत्किञ्चित् प्रष्टुमिच्छन्ति चेत् कृपया पृच्छन्तु. समयः अतीतः. And for the participants, feedback link is posted in the chat box. Please note that. I think, Anusha, we can proceed with the vote of thanks.
Yes, ma'am. Dr. Ramesh?
Yes. सर्वेभ्यः नमस्कारः। अस्मिन् संस्कृतसप्ताहस्य द्वितीयदिनकार्यक्रम भागं स्वीकृतवद्भ्यः सर्वेभ्यः अस्माकं पक्षतः हार्दिकं धन्यवादान् समर्पयामः. We thank one and all present here who are all joined in this today's section. Particularly, we thank Mr. Venkatakrishnan sir for his wonderful presentation. And once again, we are thankful to all the participants. Thank you.
Thank you, sir.
Thank you. Thank you, sir. With this, we come to the end of today's program. Tomorrow, we will meet again with yet another energetic session of learning spoken Sanskrit. Thank you, everybody.
सम्भाषणवर्गस्य अभ्यासः श्वः आरभ्य 5 दिनपर्यन्तं चलति. कृपया योजयित्वा आगच्छन्तु. सर्वाः संस्कृतेन सम्भाषणं कर्तुं शक्ताः भवन्ति चेत् आगामि वर्षतः वयं पूर्णतया संस्कृतमाध्यमेनैव एतादृशकार्यक्रमादिकं चालयितुं शक्नुमः. अस्माकं प्रार्थना.
ये अत्र पराध्यापकाः योजिताः अद्य भवन्तः छात्रान् अपि योजयन्तु श्वः कार्यक्रमे.
For tomorrow's Sambhashana Shibiram, I request all the participants who are ready to come on video. Video should be on so that we have to. It is like bhava completely in Sanskrit. Those who are ready to be in video, they should enter into Zoom meeting. So YouTube speakers, we cannot communicate with them. They can just listen the process. But here, whoever is interested, so everybody who are interested in keeping their video on throughout the session, please make their arrangement accordingly and be on time. So that we can speak Sanskritam fluently within 5 days.
Yeah. You should not miss any one of the day in between. All the 5 days you should all come.